During an investigation to make ammonia, a student uses 15 moles of nitrogen and 35 moles of hydrogen. So we've been given the number of moles, which is fairly convenient, so it's 15 and 35. What is meant by the term moles as used above? Moles means, or 1 mole contains 6,02 times 10 to the 23 particles. Calculate the number of molecules of nitrogen that were used in the reaction above. So the number of molecules is equal to number of moles times Avogadro's number, which is simply equal to 15 times by 6,02 times 10 to the 23, and I land up with 9,03 times 10 to the 24 molecules. Calculate the volume occupied by 35 moles of hydrogen gas at STP. So now we're looking at volume, and we're going to say V is equal to number of moles times Vm. 35 times 22,4, and I land up with 784 decimeters cubed. Don't forget about your units. Decide on the limiting reagent in this reaction, showing your working. So what we're going to do is we're going to say, well, if it was 15 times 3 is 45. So that is not possible. If it was 35, over here I've got a relationship 1:3 between nitrogen and hydrogen. So my relationship is a 1:3 relationship. And therefore divide 35 by 3 and I get 11,66. So that is possible, and therefore hydrogen limits me. Define the term molar mass. This is in your notes and you do have to know it for exam purposes. It is the mass in grams of 1 mole of any substance. Calculate the mass of ammonia that a student could produce from these reactions. So I now know that hydrogen is my limiting reagent, so I'm going to use the hydrogen, and its hydrogen is to ammonia as 3 is to 2, as 35 is to 23,3. What did I do to 35? I divided it by 3 and then multiplied by 2 to get 23,3. Now I can calculate mass is equal to number of moles times molar mass, 23,3. The molar mass of ammonia is 14 plus 3, which is 17, and I land up with 396,67 grams. Deduce the percentage yield of the ammonia if the student only got 51 grams. So we expected to get 396, but we only got 51. So percentage yield is equal to what did I really get out of what did I expect? And I get 12,86%. You need to be very careful about rounding here. Right, you need to keep these numbers. So here, 35 divided by 3 times by 2 is 23,3 something. Keep it in your calculator, multiply by 17. Keep this in your calculator, store it. 51 divided by that, oh, don't forget to multiply by 100 to get a percent. A group of students used the reaction between zinc and sulfuric acid to investigate how concentration affects reaction rate. The equation below represents the reaction that takes place, and they've given it to me. It is already balanced as it stands, and it's a 1:1 to 1:1 ratio, which makes my life very easy. They add 6,5 grams of zinc granules into excess sulfuric acid. That means excess sulfuric acid means that zinc is going to be limiting, because there's plenty, they tell me, of sulfuric acid. That's what it means. So what is the limiting reagent? It is going to be the zinc. What mass of zinc sulfate is produced? What is the relationship between zinc and zinc sulfate? It is a 1:1 ratio, but I don't have 1 mole. I've got 6,5 grams, which is number of moles, mass over molar mass, 6,5, and the molar mass of zinc is 65,4, which lands me with 0,1 moles. Keep it in your calculator. 0,1 is to 0,1. I think it was 0,099 something, but please be very, very careful about keeping it in your calculator. And now you go on to say that the mass of zinc sulfate is going to be that number that you stored in your calculator multiplied by the molar mass of zinc sulfate, which is going to be 65,4 plus 32 plus 4 times 16, which is 161,4. And without rounding errors, you land up with 16,14 grams. What volume of hydrogen gas is produced at STP? So if I'm going to now do a relationship, it is between zinc and hydrogen, which is again a 1-to-1. Again, I haven't got 1, I've got 0,1, so I'm going to say 0,1, but I've kept that number in my calculator is to 0,1. Volume is equal to the number of moles multiplied by molar volume, 0,1, which I stored in my calculator, times 22,4, and I land up with 2,24 decimeters cubed. Now we've got this very ugly thing, trimethyl aluminium can be prepared from aluminium and dimethyl mercury as follows. In one experiment, 5 grams of aluminium was mixed with 25 grams of dimethyl mercury and 4,5 grams of the product was recovered. Determine the limiting reagent in this and show me all the working. So the first thing I'm going to do is I'm going to say number of moles of aluminium is 5 divided by 27, which is the molar mass. I don't consider the balancing numbers at all, and I get 0,19 moles. Simultaneously, I'm going to go number of moles of mercury, dimethyl mercury, is 25 mass divided by the molar mass, which is going to be mercury plus carbon plus hydrogen, multiply the hydrogens by 6, the carbons by 2. Mercury, just keep it the same, and you land up with 230,6. That gives you 0,11 moles. Now we need to look at mole ratios. If I am going to see them as having Al is to HgCH3, 2, that is a 2 is to 3 ratio, so 0,19 is going to mean 0,285. What did I do? I divide this number by 2, multiply by 3. 0,285 is greater than 0,11, so that does not work. Let's try go the other way. 0,11 divide by 3, multiply by 2, and I get 0,07. That is less than 0,19, and so that does work. That means that dimethyl mercury is my limiting reagent. Now we say determine the percentage yield of trimethyl aluminium. Well, let's see how much trimethyl aluminium we think we should have got. So I'm going to draw up a relationship between dimethyl mercury and, whoopsie, that's a ratio sign, and trimethyl aluminium. And it's a 3 is to 2. I take the limiting reagent number of moles, divide by 3 times by 2. Remember to save all these numbers in your calculator as you're going along. And mass is equal to number of moles times molar mass, 0,07, multiplied by the aluminium, the trimethyl aluminium is 72, and I get 5,2 grams, and that would be the maximum I could get. But I didn't get that maximum. I landed up getting 4,5 grams. So in terms of calculating the percentage yield, it's equal to what did I actually get divided by what did I expect times by 100, and I get 86,54%. Indigestion can be effectively treated using an antacid. The active ingredient in commercial antacid is this salt over here, which reacts with stomach acid according to the following equation. Calculate the mass of this salt, which would be needed to react completely with 0,24 moles of hydrochloric acid. So I've been given 0,24 moles. I know that this very ugly looking salt over here and hydrochloric acid have a 1:4 ratio, 0,24. What do I need to do? Divide by 4 and times by 1. That gives me 0,06. So therefore, what is the mass that I'm going to get? Mass is equal to number of moles times molar mass, 0,06, multiplied by the molar mass of all of that, which is 144, and I get 8,64 grams. Calculate the volume of carbon dioxide that would be produced at STP if this reaction went to completion and the 0,24 moles of hydrochloric acid reacted. So again, I'm going to use all of those moles, and I'm going to say I want to see a relationship now between the hydrochloric acid and carbon dioxide, which is a 4:1, 0,24 is to 0,06. Volume is equal to number of moles times molar volume. 0,06, which I'm keeping in my calculator, although I don't think it's problematic actually. I don't think rounding really played a role in this one. 1,34 decimeters cubed. And finally, calculate the number of water molecules formed. And now I'm looking for water molecules, so it's the relationship between HCl and H2O. And that is a 4:3 relationship. And that is going to land up being 0,24 divided by 4 times by 3, 0,18. Number of particles is number of moles times Avogadro's number, 0,18 times by 6,02 times 10 to the 23. And that's going to equal 1,08 times 10 to the 23 water molecules. A mole is not a molecule, by the way, or an abbreviation for a molecule. It means something very different.